There are over 10,000 MRI units in the United States, which can be found in hospitals, private imaging centers, and mobile units. We would like to take a few minutes to educate you about the serious hazards with MRI. It is critical for firefighters, police officers, and EMS workers to know what to do and what not to do when responding to emergencies at these types of facilities. Let's first take a look at how MRI works. MRI stands for magnetic resonance imaging and uses an extremely strong magnet along with radio waves and a computer to take very detailed images of inside your body. When a patient is placed inside the magnetic field, the hydrogen molecules in the body line up like a compass. Radio waves then convert signals released from the hydrogen molecules into three-dimensional images for doctors to make a diagnosis. So just how strong are the magnets used in MRI? The magnetic field is usually measured in either Tesla or Gauss. 1 Tesla is equal to 10,000 Gauss. MRI systems used today range from 0.1 Tesla to 3 Tesla. To put this into perspective, a 3 Tesla magnet is 60,000 times stronger than the Earth's magnetic field, which is roughly 0.00005 Tesla or 0.5 Gauss. Because of the extremely strong magnetic fields used in MRI, there are serious safety precautions that must be followed. Any items containing ferromagnetic metals, such as iron, nickel, and cobalt, must never be brought anywhere near the MRI machine, especially inside the MRI room. Anyone with a pacemaker, implant, defibrillator, cerebral aneurysm clip, or hearing implant containing ferromagnetic metal may never have an MRI exam or enter the MRI room. Any loose items brought near an MRI machine can become dangerous projectiles with extreme speed and power. It is very important for firefighters, police officers, and EMS workers to remember never to bring any emergency responder equipment into the MRI rooms. In Valhalla, New York in 2001, a 6-year-old boy undergoing an MRI exam was killed by an oxygen tank that was brought into the MRI room. The tank became a guided missile when it was drawn into the magnet's bore during the exam, fracturing the boy's skull. If a patient needs to be removed from an MRI unit in an emergency, only trained MRI personnel can remove the patient using an MRI-compatible backboard, stretcher, or wheelchair. Once outside the MRI room, the patient may be either transferred to the EMS stretcher or brought to a different room to be cared for. It is very important that you do not bring your stretcher into the MRI room. Every staff member must know where the MRI-compatible equipment is located, including oxygen tanks, fire extinguishers, wheelchairs, stretchers, and sedation equipment. These items must be clearly labeled and kept in an easy access area. In addition, large signs must be visible on the doors to the MRI exam rooms, warning people about the serious dangers inside. It is important to know that MRI units are always on and running 24 hours a day, 7 days a week, 365 days a year. Coils of wire in which electricity passes create the magnetic field. These coils are cooled using liquid helium, a cryogen gas, to eliminate electrical resistance, so the magnetic field persists all day, every day, even when not in use. In the case of an emergency, there are 2 buttons to be aware of right outside the MRI exam room, near the technologist console area. One is an emergency stop-off button. This turns off all incoming electrical power to the magnet's power distribution unit, or PDU. Shutting down power may be required in emergency situations, such as fire in the computer room, fire or sparks coming from the scanning room, flooding or sprinkler systems going off, or a catastrophic equipment failure. The other emergency button is the quench button. This will cause a collapse of the superconductive magnetic field within minutes. When a system is quenched, all of the cryogens discharge at once outside the building through vent pipes. If the pipes fail during a quench, frigid helium can discharge into the MRI room. Liquid helium is roughly 450 degrees below zero and can cause severe cold burns. Pressure in the room would increase dramatically and the oxygen would be depleted as the gas expands. Asphyxia would become a strong concern. It is very important to check oxygen levels to ensure a safe environment. Due to the enormous expense of cryogen gases and the hazards created when cryogen gases are expelled, the only time a magnet is usually quenched is if a large metallic object pins or impales a person and there is no other method to prevent further injury or free the person. There is a possibility of an uncontrolled quench, which happens automatically due to a component failure or malfunction. At most facilities, the only person who can authorize the pushing of one of these two buttons would be the MRI technologist or the radiology manager. This can be a $40,000 expense. When responding to a fire at an MRI facility, normal firefighting techniques can be used while maintaining a distance of at least 10 feet from any MRI unit. Be sure to recognize any MRI rooms and do not enter unless you are completely metal-free. If there is a fire in the actual MRI room, it should be only extinguished with a non-ferromagnetic extinguisher or attacked from outside the MRI room. Be sure to locate the stop and quench buttons near the MRI technologist console area. And remember, the emergency stop button turns off electrical power to the MRI only and does not turn off the magnetic field. Upon arrival at the facility, be sure to locate the office manager, who will help guide you through the facility and alert you of any dangers to be aware of.